In this lesson, we're going to talk about graphing quadratics in standard form. So for quadratics, we have two main forms we use. We have standard form and we have vertex form. So in this video, we're going to focus on standard form. In standard form, a is the coefficient for your x squared, b is the coefficient for your x, and then c is your constant term. Now, since this is the first time we've graphed quadratics, I want to talk about the shape that we get when we're graphing a quadratic, and that shape is called a parabola. The parabola has several important parts. The first part that's important is the vertex, and the vertex is where it changes direction. So on this first parabola, the vertex is down here at the bottom, and on the parabola on the right, our vertex is here at the top. The axis of symmetry is the line of symmetry that goes right through the vertex. So all parabolas are going to have a line of symmetry. These are going to be vertical lines, and they're always going to be in the form x equals and then some number. And we'll talk about a formula we can use for some equations and different ways to find that axis of symmetry, but that axis of symmetry is always going to go right through the vertex. Then we're going to also talk about the y-intercept. The y-intercept is where your graph, where your parabola, hits the y-axis. So the y-intercept is where we know the x value is 0. So that ordered pair is always going to be 0, comma, and then a value for y. In addition to the y-intercept, we have x-intercepts, and that's where the y value is 0, and where our graph intersects the x-axis. For both of these, there are two x-intercepts. Sometimes there's only one, and sometimes the parabola never touches the x-axis at all. The last thing we have here is the maximum or minimum. And the maximum or minimum is always the highest or the lowest point. It's the y value of the vertex, because the vertex is always your highest point, like it is on this one, that's your highest one, or your lowest point, like it is on this one. And we'll practice finding both of those throughout this unit. Okay, let's do an example of graphing. When we're graphing in standard form, we have several steps that we follow. The first thing that we find is actually the axis of symmetry. So step one is to find the axis of symmetry. The nice thing about finding the axis of symmetry is there's a formula for us, and we like when we have a formula we can follow. So we have x equals, and then it's negative b divided by 2a. Remember in a formula when you see negative b, that also means the opposite of b. So when we look at our equation, we see that a has a value of 2, and b, the one that's in front of the x, has a value of negative 12, and then c is the constant term at the end, so our c value is 3. So if we want to find the axis of symmetry, we start with x equals negative b over 2a, and we plug in what we know. b is negative 12, so it's going to be a negative 12, which we know is going to result in a positive 12. And then 2 times a on the bottom, 2 times, and our a value for this equation was 2, so 2 times 2 is 4. And then we simplify that fraction. 12 divided by 4 is 3. So the axis of symmetry for this equation is at x equals 3. And so what that means is we know that the vertical line on our graph right here is where x equals 3. And the other thing we know is that our vertex is going to be on that line somewhere. So step 2 of graphing these is to find the vertex. And we know the vertex is going to have an x value of 3, and then we're looking for the y value of that vertex. To find the y value, we take our original equation, y equals 2x squared minus 12x plus 3, and everywhere that we see an x, we're going to plug in our x value of 3. So our equation is going to look like y equals 2 times, that's going to be 3 squared, minus 12 times 3, plus 3. When you're substituting this in, it's important to be very careful with your calculations. Be sure that you square the x value, and then you multiply it times its coefficient. So y is going to be equal to 2 times 9, because 3 squared is 9, so that's going to give us 18, minus 12 times 3 is 36, and then plus 3. So 18 minus 36 is negative 18, plus 3 is going to be negative 15. So our vertex, we said it had an x value of 3, and now we found it has a y value of negative 15. Now we're ready to plot that point on our graph, but if you notice, it's probably not going to work if I count each one of these lines as 1. So what I'm going to do is on my y-axis, I'm going to make each tick mark worth 3, so that's going to be positive 3. This is going to be negative 3. So when I plot 3, negative 15, I'm going to go over 3 because I didn't change the value on the x, and down 3, 6, 9, 12, 15. And now I've got my vertex right there at 3, negative 15. And then the next thing I'm going to want to graph is my y-intercept. So we said the y-intercept is when x has a value of 0. So step 3, we're going to say is the y-intercept, and that x is equal to 0. So we're going to take our equation, the same equation, and we're going to substitute in a 0 for x. So it's going to be 2 times 0 squared minus 12 times 0 plus 3. So 0 squared is 0 times 2 is 0. So this is 0 minus 12 times 0 is another 0 plus 3 equals 3. So our y-intercept is at 0, 3. We'll plot that point right there on our graph. And then what we want to do now is use that line of symmetry that we graph. We have this line of symmetry right here, and we know that if our y-intercept is 3 away, 1, 2, 3, that direction for the y-intercept, we can go 1, 2, 3, this direction to get our other point, and then we can kind of sketch our curve right in there. And our parabola is going to look something like that. Eventually we're going to talk more about finding some better points so that we get a nice curve on there, but there's the basics of how to graph using standard form.